All right, day 21 of Advent of Code. Here we go. Okay, each one just expresses result of a math operation. Okay, this is fine. We can do this with memo-ized recursion. Yeah, I think this is just eval. Well, it's not quite eval, but okay. Okay, so we have this now, and what we're gonna do is let's just repeatedly evaluate everything until we get the answer. That seems reasonable. Okay, these are 4 letters, that's fine. It's the len of x. Can we n squared this? It's borderline, but we will. While cool. I think that's fine actually. Yeah, and then root. Oops. So this is a little bad. It's very bad actually. And then if we succeed, let's do like new x, and then if we succeed, we do nothing, otherwise we're gonna add it to new x. Cool, and then x equals new x, and new x. And that'll tell us what the bug is. So what's going wrong here? Oh, well, for starters, I think we care about, this is probably division. It's probably in division, is my guess. So maybe it's not. Did this immediately. Oh. Okay. So let's do this in x, and then x is nx now. Wait, what? I have a bug. It's not good. Why? If we succeed in evaluating it, it shouldn't make it into the next round, right? Oh, whoops. It's a statement. Okay, cool. That's a number. Rank 41. Misunderstood a few details. Correct operation for root should be equals. Still listens for 2 numbers. Now checks they match. Figure out what number. Ooh, that's a little bit annoying. Let's just try this. I think I'll just play with it because there's only one equality. So we'll do this still. And then when we finish, we can get rid of that. So while it's equal to this, so now root is going to be actually, I want to keep that. If we not equal to root, else what is my root operation? Okay, otherwise, it's going to be the first 5 plus equals plus 6, 7 onwards, I think. That seems about right. Let's put in parentheses. Yeah, that seems good. And what we'll do now is oh my god, I'm typoing. Typoing and writing bugs. Okay, that's fine. Let's do 6 instead, but that should be good. Cool, so I think that's gonna be the same. So we'll equal to this, and then what we'll do is instead we will return RH and HCGL. This will tell us what the two numbers are. And the other thing we need to do here is we need to get rid of this if b not equal. And now what we will do is we set this to just be here. Okay, and now we can just attempt. So for 0, oops. So if for 0 we mess up. So here we can do, let's call it like mx. And this can become mx, this become mx. Oh, it's still going, that's not good. Let's print, so we have hum n. It shouldn't matter, but just once again, we'll do this. Oh, it's 0, but root was not set to anything. Yeah, so why is it not setting it to anything? Okay, so this is never printing, so these are never getting set. That's a little bit weird. Why is that happening? Oops, I think I need that. God, I have a bug in here somewhere, I just don't know where. So this list becomes empty. Okay, let's do this. Am I using the variable somewhere? So it should have been set. And if it's not set anymore, it means that it succeeded. So somehow it was fine setting root equal to something. Oh, fine. We'll just do this. If it's root. Oh, is it because locals are doing something funky? That could be bad, but let's not worry about it for now. So if it's equal to root, then we'll just try. Let's do this. Let's first do this. Or if b is not equal to root, else we're going to root equals eval b. Okay, so it did a thing, like a thing. There should only be 2,000 of these lines, right? Because every time we print this, mx should get smaller. Yeah. Okay. So some things are happening that are interesting. So it's throwing an error, right? It got set though. Did it only get set in this context? Do I believe that? Whoops, let's get rid of these prints. Okay. Okay, so return some numbers. These look any different? They do look different. Make this really big. Okay, that was too big. Cool, so we can kind of binary search on this. I mean, it can technically make like quadratic expressions. It can make like any polynomial here, so this could be really bad. Can it make anything non-polynomial actually? I don't think it can, unless it has like int division, which it does not. So maybe we can do this. How do I want to do this? Let's do like randomized hill climbing or something. So the first one is like is us goal is attempt 0, and what we'll do, cur will be like 0 and inc is like 1e. What is this? Is that 1e10 or something? 1e11 maybe? It's 1e11, yeah. And what we'll do is, let's do this. So it's strictly less than the distance to us to the goal. Oh wait, whoops. Attempt, and we're gonna give it cur. Yeah, just attempt of cur. If adding inc is strictly better than subtracting it, or sorry, than doing nothing, then we add it. Otherwise, if subtracting it is strictly better, then we subtract it. Yes, this is inefficient. No, I don't care. And at some point here, maybe like every 20, we'll just like half the increment. And we'll just print the cur. And we'll see if this works. I doubt it will, but whoa. Is that what it's... Is it printing this? Wait, what? I doubt it. Hang on. Print cur. Oh, it's printing this. I didn't want to print that anymore. How slow is this really? Okay, so it settled on that. Interesting. It is for sure doing a thing. Seems to really like getting close to 4,000 for some reason, maybe? Maybe not. Yeah, I don't know about this one. I guess meantime I can write something smart. This doesn't seem like right at all, though. Okay, so what we can do is we can keep things in terms of us when we evaluate. That's going to be a little bit annoying. Let's see. what can we do? We can substitute each thing with another thing. Let's see. Yeah, let's do this. Let's start with the root. And what we'll do... Okay, I've got it. This is going to be... this might not work. This probably won't work. Also, it does not like this. Just try like a different randomization. Yeah, it just bounces around way too much, and then it likes to go towards like an even... I don't even know why this is happening. But it seems very wrong. Okay. My cheesy idea was to just like throw this all, like actually get an expression. So I guess half of it can be simplified, right? Anything, so we know that we're trying to make, how do we do this? Yeah, so we can get like an expression of the form. Okay, so hunting on this is not going to work. The root thing is fine. We're excluding hum n. That's also fine, I think. So what we'll do... keep a dictionary. And for... This is just going to be like a string whose value is x. What we'll do is for e in x, if so we'll try and evaluate e basically, or yeah, so like the new e, we're going to try and map. So we're going to replace M1 with M2. And if x is in NE, then there's not a whole lot we can do about it. We're just going to have to leave x in NE. And in this case, we're going to say, oops, oh, so also if v is in vels, we're going to skip it. Cool. So if we have an x, then, oh well, vals of v is going to be the new expression, which will be like some expression in terms of x. Otherwise, we should, well, we'll try and evaluate it. And if we fail, oh well, we just keep going. And what we'll do, look at the len of vals, replace must be string, not int. These should all be, oh, we can cast this to a string. I think it's fine. Okay. Okay, cool. And then once we're up here, now what we do, okay, we have an expression now. And we can maybe open up Sage. So where's the x in this, actually? There's one x here. How many x's are there? Is it just the one? Oh, it's just the one. If it's just the one, then we can do, it's going to be this plus x minus this. Wait. Oh. Parentheses are a thing. We need to replace it with like parenthesis m2. Okay. That may cause problems, but cool. That should still be fine. Okay, so we're going to do x equals var x, and then we're just going to do it. We're just going to tell it to solve it, and it will just do it, hopefully. But it's going to take a... Sage is really slow to load. This is kind of sad. Okay. And let's just solve this. Solve this in terms of x, please. Oh, that's a number? Why is it a fraction? That's a little questionable. That's very questionable. Oh, that's right. Okay. Oh, but rank 208. That's pretty slow. Okay. Why is it off? Why is it off by a little bit? Is this really integer division? I thought it was like regular division. And that you just sort of assume that things are like they need to be divisible. Why is it it's so weird? Like if we do mod, like there's actually a remainder of 1. Something it's okay. Yeah, cool. Well, that's day 21. Let me look at the leaderboard. I'm curious how fast people solve that. What would be the good way of doing this? Because even once you get an expression in terms of x, you can still like do stuff with it, right? Like I didn't really do any of the stuff with it at this point. Actually, can you? You should be able to. But anyways, I wonder if this could be simplified. Could I just put this in? I simplify. Will it do it? It's probably a floating point error that this came up with the wrong. It probably is, but at the same time, if I do this, like Sage keeps it exact, right? Oh, but there are some floating points in here. So I bet if I get rid of the floating points, it fixes the issue. So if we did like z.replace 0.0 with nothing, I bet if I put this in here, it would give me the exact answer. X, please. Oh yeah, immediate correct answer. Yeah, I mean, okay. I forgot I was gonna look at the times here. Let's see. Both stars. First one in 5 minutes. That's crazy. What did it take me? 20 minutes? Yeah. Okay. 16 for cap. Okay. Yeah, I think I definitely spent more than. Did I? I probably spent more than 5 minutes with the whole like randomized hill climbing. This is not randomized, but like this hill climbing type thing. I am almost a little surprised that this didn't work because this expression should just be like linear in x. Like I'm pretty sure there's only one x here. See if I simplify it, what it will tell me. Whoops, wrong one. If I simplify this, yeah, that's linear. Yeah, oh wait. What was I doing? I was doing absolute distance, right? I wonder if I did like a gradient descent if that would have worked. Kind of curious. Well, why don't we try it? So let's do like so I do want to keep this just as like what I originally did. Distance of attempt like plus ink. So this is like how much better it gets when we add ink. And basically Wait, was I doing curve? What is us? Oh, this is not even used. Oops. Again, I want to keep it for the original. But if we do like, let's see. So this is positive. That's bad. So yeah, it's gradient descent. So subtracting the gradient. And then I need to divide by like the increment. And then this can be, I don't know. I mean, you can make it like 100 or something. I don't think it really matters. And then this would be divided by 100. But like this is really going to get baked into a learning rate. For starters, let's do this and see what it does. It's increasing. Let's do like, it still seems pretty slow. I mean, to be fair, the gradient here is like, is constant. Wait. Yeah, well, it's like, it's piecewise constant, either +1 or -1. What's the actual answer? That's pretty big in comparison. I mean, what could we do? Let's see. I mean, I guess we could do this squared, you know. So if that's our loss function, then I think this will still work. But now I shouldn't really have to tune the learning rate that much because it's actually like, it just breaks. Figures. Oh, does it actually get there? Oh, that's so cool. 3, 4, 5, 3, 7, 4, 8, 2, 4, 8, 2, 2. Oh, that is so cool. I mean, it's obvious, right? Like, it's a linear function, so like, clearly it should get there. It's kind of stuck here though, so I guess that wouldn't quite have worked. I wonder if I upped the learning rate here, how that would have done. Yeah, I don't know. Oh, maybe it's the case that the grad is. Oh, yeah. It's because the gradient here is now 0 because like 100 here is like, oh yeah, that's the problem. 100 just overshoots it. So if we do something like 1, that will work better, I think. Yeah, let's, okay, the gradient is actually set pretty high right now. 220, 116. 6, it's close. If you round it like a little bit extra. Okay, fine. So if we do this, surely now it will actually like converge properly. 220, 116. Come on, you gotta call that 6. All right, cool. So I'm very satisfied knowing that gradient descent actually does work here. Neat. I don't know how I didn't realize it was linear. Like, when I was attempting this, I think I started playing with it and then I realized like, oh, it must be nonlinear function, and then immediately punted that idea, when if I had maybe thought about it like a little more carefully, I would have been able to get it with that approach. Alternatively, if I had just gone straight for the second approach, I think that also would have been pretty fast. I think this one probably was like I couldn't make up my mind, and that was the issue. But yeah, cool. That is a cool challenge. It's pretty neat that gradient descent actually works, and probably could have been competitive. But oh well. I'll be curious to see if anyone else did that. But yeah, that's all for day 21. I will call the recording here.